These next few videos will introduce classes differently than the textbook. Classes add a number of concepts you need to learn, so it takes a while for most people to fully grasp how to effectively write and use classes. If you don't feel comfortable with the concepts after watching the first few videos that introduce classes, try reading the alternate introduction to classes in the book. A class is a way to define a new data type that combines related data and the methods for manipulating that data. We use the term object to indicate a variable whose type is a class. Python has a number of built-in classes, such as the string and list data types we have already used. The string class combines the sequence of characters that the string consists of and methods such as split, join, and upper that operate on that data. The list class contains a sequence of values, along with methods such as append and sort. When we create a string, we refer to that object as an instance of the string class. Equivalently, we may say it is an object of the string class. The methods that manipulate the data of a class are functions that must be used with a specific instance of the type. As we have seen when calling methods, you write an instance of the class followed by a period, and then the name of the method and any additional parameters that method takes. The instance before the period is the data that is used in that method. Here is a quick review of some of the string methods. We create a couple strings and call the split method with s1. This returns a list of strings by splitting s1 at each whitespace character. This method does not change s1 because strings are immutable. Instead, it returns a list with new strings. When we call the split method with s2 and pass the comma, it uses the string s2 as the string to split and returns a list of strings splitting s2 at each comma. Again, s2 is not modified, but a list with new strings is returned. The join method is called with a string that indicates the string to place between each string in the list it is passed as a parameter. Neither the string it is called with or the list are modified. A new string is returned. We saw in the videos for the previous chapters that splitting a problem into subproblems and writing a function for each subproblem is one way to solve larger problems. We have also used classes such as the built-in string and list classes and the graphics classes the textbook author wrote. Objects are useful when we have data that is grouped together and want to perform operations on that data. We call the operations on that data methods. For example, the various shape objects all have a method named draw that operates on that object and the graph window it is passed to draw it in the window. Functions and methods are very similar. Methods are functions that are always called with data representing a specific object. For example, we could create a graph when in a circle and call the draw method for that circle. It would use the data for that circle, which is a point representing the center and the radius. The graphics objects also have values that indicate the color, but provide default values for those if you do not set them. If we had not organized the circle data into a class with methods, we would need to call a draw function and pass all the data. By encapsulating the data into a circle object with methods, the code is more organized and more clear. It also allows us to more easily reuse the circle class in multiple programs. Classes have a number of benefits, and they have become the common approach to developing modern code. They allow us to organize the code. They also allow us to easily reuse them in multiple programs, as we've seen with the classes from the graphics module. Classes also allow us to abstract or hide the details from the person using the class. We did not need to know how the graphics classes work. We just needed to know how to use them. The information that indicates how to use the class is known as the Application Programming Interface, or API. This is the documentation that indicates the name of the method, what the parameters are, and what the method does. Programs can be written without classes, but as we've discussed, using classes makes the code more clear and more organized. An indicator that you should use a class is when you are using multiple pieces of data to represent something, and there are operations that work on those pieces of data. This is especially true when operations mutate the data. The first two lines here show what a function to move a point without using classes might look like. The next two lines show how it might look when using a class. This is more organized with fewer parameters and return values. If you think about the built-in string and list classes, you will see they meet these guidelines. The string class organizes a sequence of characters with operations that process the data as a whole. The list class organizes a sequence of values with operations that process the data as a whole, and many of its methods mutate the data. A key concept of classes is a method to create the object and initialize the data. The generic term for this method is the constructor. The string class uses quotes, and the list class uses square brackets to initialize them. For classes that are not built into the language, we use the name of the class to construct the object as we've seen when creating point and other graphics objects. After the name of the object, you put parentheses and any parameters needed to initialize the object. Each call to the constructor creates a separate object. Assigning one variable to another variable makes both objects point to the same object. Which one you want to use depends on the context of what you are trying to accomplish. When writing a constructor, you should think about all the data needed for that object and initialize it in the constructor. A two-dimensional point needs numbers to represent its coordinate. The constructor should initialize this data. In some cases, the code that uses the class should supply them if they could vary, as they do for a point. For other classes, such as a class to represent the 52 cards of a card deck, there is no need to supply parameters, as the cards will always be initialized to the same 52 values. In the next few videos, we'll look at a couple different classes to help you understand the concepts, so you can learn how to write your own classes.